Okay, problem 14. Consider the reduced sphere unit cell shown in problem 3.22 having an origin of the coordinate system positioned at the atom labeled with an O. For the following sets of planes, determine which are equivalent. Okay, so there is part A and part B. So we need to determine which planes are equivalent. So the planes will be equivalent if they have the same atomic density along those planes. So let's see this in part A. First see this plane. So in part A, first see this plane 0 0 minus 1. So 0 0 1 bar plane will be the plane which will be parallel to x and y axis, and it will be at an intercept of -1 from the z axis. So we take the origin over here, and then -1 will be here. So this will be the plane. Okay. So since this dimension is 0.3, 0.3, so this plane will have a square dimension 0.3 and 0.3. What is the other plane? We can show 0 1 0. Okay, there is 0 1 0 plane. So 0 1 0 plane will be parallel to x and z axis. Okay, so it will be along this plane, and if I take this origin, so 1 will be here. Okay, so 0 1 0 plane will be here, so because it is parallel to x and z axis, so this 0 1 0 plane. So as we can see that this 0 1 0 plane has dimensions of 0.3 by 0.4 nanometer. So 0 0 1 bar and 0 1 0 are not equivalent. Okay, so let's see what is this plane 1 bar 0 0. So 1 bar 0 0 will be the plane which will be parallel to y and z axis, and due to 1 bar we will need to take an origin over here. Okay, and then that will be in -1, that will be this direction, that will be this plane. So let's show it with some other color. Okay, so this will be this plane, the back side of that plane. So what are the dimensions of this plane on the back side? So the dimensions of this plane will be 0.3 by 0.4. Okay, so let me write it down. The first plane was this one, 0 0 1 bar. Okay, and that was 0 0 1 bar. Y. So this plane was 0.3 by 0.3. Okay, with 4 atoms along 4 corners. The other plane is which one? 0 1 0. Okay, 0 1 0 was this plane. So 0 1 0, this plane, it was having dimensions of 0.3 by 0.4. Okay, and the third plane was 1 bar 0 0, 1 bar 0 0 over here. So it has the dimension of 0.3 by 0.4. So 0.3 by 0.4. So these two planes, okay, 0 1 0 and 0 1 0 0, have the same dimensions and the same number of atoms. So for example, this 1 0 0 plane will also have 4 atoms at the corners. Remember that this is a body centered structure, body centered cube structure, crystalline structure. The central atom will not figure out in any of these planes. So our answer is 0 1 0 and 1 bar 0 0 are the equivalent planes, whereas this 0 0 1 bar is not equivalent to the other planes. So I can write it like 0 1 0 is equivalent to, so I can put these three bars over here to show equivalent to 1 bar 0 0. Okay, next is need to check about this plane, part B. In part B, okay, so we need to find which planes are equivalent. So we need to draw these planes. So 1 1 bar 0, okay, 1 1 bar 0. So we can draw this plane 1 1 bar 0. So since at y coordinate there is 1 bar negative value, so we will take origin here, and from this origin we will go to this 1 and then this -1, and then we will combine these two together. Since the z coordinate is 0 over here, so this plane is parallel to z axis. So from this coordinate you can draw a line parallel to z axis, which is already this line, and then from this coordinate we can draw a line parallel to z axis, which is also this point. So we can combine these 2 points together, and this is our plane. So this plane has this kind of dimensions. Okay, so this dimension is 0.3 and this dimension is 0.4, and there is an atom here, there is an atom here, there is an atom here, and there is a central atom here as well. Okay, so how about the second plane? Second plane is 1 0 1 bar. Okay, 1 0 1 bar. 1 0 1 bar. For this you will take a origin at here, because here it was negative, so you take a origin at here, so 1 will be here, okay, and then 1 bar will be here, and this plane is parallel to z-axis, okay, sorry, y-axis, sorry, it's y-axis. So we will join this point over here, and a line parallel to the y-axis will intersect here, a line parallel to y-axis will intersect here, so we will join these 2 points over here as well. Okay, so this will be the plane. So this will be the plane. So for this plane, you can see that this dimension is 0.3. So this, for example, one dimension is 0.3. The other dimension is because it is an inclined, so it is 0.3, 0.4. So if it is, for example, it is like a triangle like this. So if it is 0.3 is here, if it is 0.4 is here, 0.3 is here, so this will be 0.5. So this is this dimension is 0.5, and then there is one atom here, one atom here, one atom here, another atom here, and since this is passes through the middle, so there will be an atom in the middle as well. But you can see that this plane is now different from this plane. It's not equivalent. Okay, so let's see another one, the third one. The third plane is 0 1 bar 1. Okay, 0 1 bar 1. So let's draw it. So its origin will be here. Okay, yeah, origin will be here, and for y-axis the one point is here, the other point will be here. Okay, these will be the 2 points, and since it is parallel to x-axis, the next opposite point will be here, and the opposite point over here will be here. So this plane will look like a little bit acute because of the angle because of the direction where we are seeing it. Okay, so it will be like this. Yeah, I think it will not draw well over here, but anyway, it's like it is a rectangular plane anyway. It will be a rectangular plane. So for example, joining these points A, B, C, D, it will be a rectangle anyway. So it will be 0.3 here, 0.3 nanometer long, 0.3 nanometer long, and lengthwise it will be 0.3 and 0.4. okay, so it will be 0.5. it will be a triangular. Okay, and then there will be 1 2 3 4. So this plane will be equivalent to 0 1 bar 1 will be equivalent to this plane. Okay, 1 0 1 bar, same dimensions. Okay, the third one, the last one was 1 1 1 bar 1 bar 0. Okay, so 1 bar 0. So 1 bar. So we will take the origin at from 0 in the x direction 1 unit, and in the y direction 1 unit. So this will be the origin, changed origin. So go from this origin negative x direction over here, and negative y direction. Sorry, this is the negative y direction, and then this is the negative x direction. Okay, so now we can join these 2 points, and since this plane is parallel to z axis, so the opposite points will be here. Okay, so I can join, so I can shade it. So this is the approximate shading for this plane. Okay, so now this plane is having dimensions of what? So the length is 0.3. Okay, 0.3, 0.3. This is 0.3, 0.3. So it will be 0.48 from the Pythagoras theorem, 0.48, and the height is 0.4. And if we see that this will have only 4 atoms at the corner, and the fifth one, of course, because it is the body center. So this plane will be equivalent to this first one, 1 bar 0. Actually, it should be 0.3, because this dimension is 0.4. This dimension should be 0.48, because